Collisions. Yeah, the thing that happens when something forgets to stop. Whether it's you walking into a door, a driver forgetting how brakes work, or just your face colliding with reality. Literally, we see them every day. In sports, in traffic, in life, sometimes in slow motion, sometimes before we've had coffee. But behind every bonk, bump, and oops, there's physics, real, actual physics, like math and numbers and momentum. I know, tragic. So today we're breaking it down, because apparently me failing the collisions unit wasn't enough trauma the first time. This is Collisions, a chaotic love story between mass and velocity. Not all collisions are created equal. Elastic ones are like those clean bounces. Think pool balls or bumper cars. Inelastic ones? That's when things collide and cling harder than that couple who swear they're just friends. Perfectly inelastic means they stick together, moving as one after impact. Momentum is still conserved, but kinetic energy? Her work here is done. Momentum covers her shift. All right, class, or whoever's watching this, today we're watching two blocks beef it out. First up, we've got a 3-kilogram block, moving right at 8 meters per second. Confident, heavy, probably listens to motivational podcasts. Coming up ahead is a 1-kilogram block, also moving to the right, but only at 4 meters per second. It's trying its best. So what happens when they meet? Do they hug it out? Nah, this is an elastic collision, which means nobody sticks together and no kinetic energy goes missing. They bounce off each other and keep it moving. No feelings involved. So let's talk numbers.
First, momentum. You gotta multiply the mass and velocity of both blocks and add them up. Final answer, 28 kilogram meters per second. Then, kinetic energy. You're doing that classic 1/2 times mass times velocity squared for both. Total energy before the collision, 104 joules. Still with me?
Y'all are going to jail! Get over here!
Don't zone out now. Here comes the bounce. After the collision, the big block slows down. It's now cruising at 6 meters per second. The small block, it takes off like it just heard the lunch bell. Now flying at 10 meters per second. No momentum lost, no energy gone. It's all still there, just redistributed. That?
A lot of boring math later.
That, my friends, is how elastic collisions work. Quick, clean, and a little dramatic.
Don't be that person who mixes up mass and velocity. Trust me, I know. It happens to the worst of us. Momentum is a vector, so direction matters. Decide which direction is negative to you, but keep it consistent. If you're not smart enough for that, just say the direction. Also, momentum and kinetic energy are not twins. They're barely cousins. One's m times v, the other's 1/2 m times v squared. Big difference. Don't flop. Collisions are basically just momentum dramas. The law of conservation of momentum says, whatever momentum you had before, you gotta keep after. Like karma, but with numbers. So if a heavy truck hits a tiny car, that force is shared. It's messy. It's beautiful. It's physics. Just remember, momentum equals mass times velocity. So the faster and heavier something is, the more oomph it brings. So, collisions. We know what they are, how they work, and how not to fail them again. Momentum's conserved, energy might not be, and you better watch your signs. Collisions. They happen fast, hit hard, and if you're not paying attention, they'll take your physics grade average down with them.
Hoochie coochie!